Right, this is 7.2.1, Newton's law of gravitation and gravitational field strength. So in this lesson, we're going to aim to define Newton's law of gravitation. We're then going to use that to construct an equation and the behavior of an equation. And then we're going to define what gravitational field strength means and how that relates to our prior knowledge. So first of all, we're going to consider two masses that are separated by some distance and how they interact together. So we say we have a mass, we'll label this one M1, and we have a smaller mass M2. We denote the separation between them as R. This separation is between the center of their masses. Now these two masses are going to exert a force on each other. This is going to be an attractive force, which we call the gravitational force. So Newton's law of gravitation says that the gravitational force between 2 point masses is directly proportional to the product of the masses and inversely proportional to the square of separation. This is a definition you must learn, so let's put a box around it. And then we'll deconstruct what this means. So first of all, these two masses exert a force on each other. It will be an equal and opposite force. We call this the gravitational force. And the force between these 2 point masses, so we will extract an equation out of this, F, is directly proportional to, so we write the proportionality symbol, the product of the masses. So the product of the masses means multiply M1 by M2. And inversely proportional to the square of separation. That means it's proportional to 1 over r squared. Now we notice something about this definition is that it takes the masses to be point masses. That means that in space, rather than looking at the actual volume that these objects are occupying, we treat them as if they occupy only a single point. So we take that point to be the center of their masses. Now, for us, this equation is not very useful as it's a proportionality equation. So I will then give you the constant of proportionality to turn this into a useful equation, which is F is equal to G M1 M2 all over r squared. Now, big G is called the universal gravitational constant. This is not the same as little g, which you guys already know as being 9.8 newtons per kilogram on the surface of the Earth. This is a constant that is used to make this equation work. And the value for big G is 6.67 times 10 to the minus 11 newtons meters squared per kilogram squared. So we use the word gravitational field strength. This is little g that you guys already know from your prior knowledge. Little g on the surface of the Earth is 9.81 newtons per kilogram. But we have to define what exactly the gravitational field strength means. So the gravitational field strength is the force acting per unit mass is the force acting per unit mass in that gravitational field So as an equation, if we consider force acting per unit mass, the word per usually should remind you that it's a division. So gravitational field strength G is the force acting F per unit mass divided by m. So this equation should remind you of F equals mg. In fact, it is the same equation, just rearranged. So this equation is used near the surface of a planet, where the gravitational field is uniform. G is measured in units newtons per kilogram or meters per second squared. So it is also the acceleration due to gravity. Now we've been using a word here, gravitational field. So we have to be able to define what gravitational field also is. So the gravitational field, a gravitational field is a region in space where a mass experiences a force. So if you have an object that has a mass, which is all objects, in a gravitational field, they will experience some force. And the forces of a gravitational field are always attractive. They are never repulsive. And that now is the end of 7.2.1.